Welcome back to Chapter 11. This is the last section that we're going to go over in this chapter, and this will complete our discussion of intermolecular forces. In this part, what we're going to do is we're going to look at these intermolecular forces that we learned about in parts 1 and 2, hydrogen bonding, dipole, ion, dipole, etc. And then we're going to look at how that actually affects some really cool properties of liquids. So those include surface tension, viscosity, capillary action, and then a meniscus, which if you've been in lab, you may have seen before. So viscosity is kind of how thick something is. Okay, when I think of something that's viscous, I think of honey or molasses, something that's really thick. The real definition, though, is the resistance to flow. So how much it kind of sticks to the side of something, or it just resists, just running freely. Now, if you pour water goes really quickly, okay? So it has a very low viscosity. But honey, molasses, pancake syrup, things like that, they have a very high viscosity because they resist flow. One place we see this is the viscosity of oil in your car. So if you've ever paid any attention, some cars use 10W30, some use 5W30. And what that is 30, I believe, is the temperature, the low temperature, and that describes the viscosity of the material at that low temperature. And so, some oils are thicker than others and will flow and resist flow more. So instead of thick, we now know that means they're more viscous. Surface tension is something that we see with water a lot. This is the unequal attractions that occur at the surface of a liquid. Okay, so at the surface of the liquid, you have these attractions between your plus and your minuses, and some of them you'll have the negative end sticking up, and some of them you'll have the positive end sticking up, and so that makes that an uneven attraction on that surface. And what it does is it causes them to kind of hold together and form almost like a film on the top. And so like in water, that's why a water drop, if you put it on a table, it'll tend to have this shape. That's due to the surface tension of those molecules. If you've ever seen, I call them skeeter bugs, but they're very light. They have long legs, and they can, if you're at the creek or something, I know, you see, I'm in the country, so but they can stand on the water literally, okay, and they can walk across the water and everything, and it's because they can utilize the surface tension on the surface of that water. Capillary action is the ability to rise or fall in a glass tube, okay, and capillary action, so if you've ever had a test where they prick your finger and then they've got this tiny little tube that they stick on there, okay, and you'll see if you watch it, if you don't pass out, that the liquid will flow up that tube. That's called capillary action. And the reason this happens is because you have cohesive forces that hold the liquid together, and then you have adhesive forces that will stick to the sides of the container. And so if you have rise in this little capillary tube, if it rises, that means that your adhesive forces against the sides of the container are stronger than the cohesive forces between the molecules. If it falls, that means the cohesive forces were stronger than the adhesive. And you really see this on glass, and in the lab a lot of times you'll see it on glassware. And this is what forms the phenomenon of the meniscus, okay? Because the adhesive forces to the glass from that molecule is stronger than the cohesive forces between the water molecules. What's cool to note is we don't use mercury very much in the labs because we figured out how toxic it is and it can make you go crazy. But you see a concave meniscus in water because of this adhesive. You see a convex in the mercury, and the convex is forms because the interactive forces between the mercury molecules are stronger than the attraction between the mercury and the glass. And then vice versa for the water, the adhesive is stronger between the glass and the water molecules that are touching it and the water molecules that are not. So it's kind of cool. You get two different types of meniscus. We don't get to see the mercury one except in pictures so much because it will absorb through your skin and it's a neurotoxin, so bad. Okay, and that's it. So we have now looked at all our intermolecular forces, the different types in depth, and how they could affect solubility, and then how they could affect the cool properties of cohesiveness and things that give water its very unique properties. All right.